This is section 3.2, quadratic equations, functions, and zeros. Now there's a difference between a quadratic equation and a quadratic function. A quadratic equation, set equal to 0. Quadratic function is typically written in f of x equals or y equals. And you're generally going to see it in the form of ax squared plus bx plus c. Now this form of ax squared plus bx plus c equals 0, we call that standard form. Now it's important because you're going to see that form in other areas. Now we're going to be learning 4 different ways in how to solve an equation. Two of them we'll review. So the first one was zero product. We said by definition if a times b equals 0, then we know that either a is 0 or b is going to be 0. And so we typically see that in factoring. So I subtract 3 on both sides, and so I got 2x squared minus x minus 3 equals 0. Now I can factor this. So this will factor into 2x minus 3 and x plus 1. And so I can say now that each one of these I set it equal to 0, so 2x minus 3 equals 0 and x plus 1 equals 0. So add 3 to both sides, 2x equals 3, divide both sides by 2, x equals 3 halves. And then here subtract 1 on both sides, x equals -1. Now example 2, this was the second way that we learned, is the square root method. Here you would get the x squared portion by itself, and so I'd get 2x squared equals 10, divide everything by 2, and so I get x squared equals 5. Then I can take the square root to both sides, and I get x equals plus or minus the square root of 5, which would be my answer. Now what happens when you finding these real solutions? Notice that if I factored this, right, let's say if this is my equation, and I set it equal to 0, and I solved it, and so I factored it, and I got x equals -3 and -5 from doing that. When you get real solutions, it's where the graph crosses the x-axis. So it crosses here at -5 and here at -3. Even if I did this with the square root method, add the 9, take the square root of both sides, and that's how I got x equals plus or minus 3. It crossed at -3 and +3. Now, if you ever get imaginary solutions, so like here where I subtract the 4 and I take the square root of -4, so I got plus or minus 2i, it means that the graph does not cross the x-axis. And notice, here's my graph. It did not cross the x-axis down there. Now, another method in finding these zeros is going to be completing the square. Now, the way we do it is we take the problem and we set it equal to 0. So I'm going to say x squared minus 6x minus 10 equals 0. Then I want to add or subtract c to both sides, so I'm going to add the 10 to both sides. And so I get x squared minus 6x equals 10. Then, if I have an a, so that's the number in front here, if I have a number other than 1, I can divide everything by it. I don't, so I don't need to worry about it. Now step 4 says I need to take b divided by 2 squared and add that to both sides. So here's my b, so I take -6, divide it by 2, square it, and I'm going to add that to both sides. So I'm going to get x squared minus 6x plus 9 equals 10 plus 9, which is the same as x squared minus 6x plus 9 equals 19. Now the reason why we completed the square is because this portion here is now always going to factor. And so this will factor into x minus 3 squared. You can factor into x minus x and x minus x, and that's how we get that. And this still equals 19. Now I'm going to rewrite it up here. Now I can take the square root to both sides, and so I get x minus 3 equals plus or minus the square root of 19. Add the 3 to both sides, and so I get x equals 3 plus or minus root 19. Now for my math lab, even though this is an acceptable answer, you might have to break it into like x equals 3 plus root 19 and 3 minus root 19. So just be careful of that. For this second example, first thing I want to do is set the problem equal to 0. So I want to subtract 3x on both sides. And so I'm going to get 2x squared minus 3x minus 1 equals 0. Now I want to add and subtract that c, which is step 2. And so I get 2x squared minus 3x equals 1. Now divide by a, so I'm going to divide everything by 2. So that's going to cancel out, and I'm going to get x squared minus 3 halves x equals 1 half. Now this is where I can do step 4, b over 2 squared, and add that to both sides. So negative 3 over 2, so that's my b, over 2 squared. Simplifying that, those two numbers multiply together, so I get negative 3 over 4 squared, which is the same as 9 over 16. I want to take that 9 over 16 and add that to both sides. So I'm going to get x squared minus 3 over 2x plus 9 over 16 equals 1 half plus 9 over 16. Now you're looking at this and it's just a mess. This looks yucky to even try and factor because that's going to be our next step. Now a hint is going to be this value is going to be the value that's going to be inside when you factor it. So I can factor it like this, x minus 3/4 squared. So that value is going to be the same. You can go ahead and rewind this video and verify that on the other example I did, because I guarantee you that would be the same. And so this is going to equal 1 half plus 9 over 16. I can combine these together, multiplying by top and bottom by 8 over 8. And so that's going to turn into 8 over 16, which adding together gives me 17 over 16. So rewriting this up here, I get x minus 3 over 4 squared equals 17 over 16. Now I need to take the square root to both sides, and so I get x minus 3 over 4 equals plus or minus the square root of 17 over 16. So I get x minus 3 over 4 equals plus or minus the square root of 17 over 4, right? Because the square root of 16 is 4. Add the 3/4 to both sides, and you'll get x equals 3 plus or minus the square root of 17 all over 4, since they both have the same denominator. Like I said, with my math lab, you might have to separate the plus and the minus. Now, the go-to formula, the quadratic formula. Now, you can use this formula to solve any quadratic equation. And there's actually a really cool proof on how to solve it on page 179 in the textbook. So if you wanted to take a look at that proof, I highly recommend it. It shows you actually how they derive that equation. So to do this, we have to first know that our equation's in standard form, and right now it's not. So you'd have to subtract 7 on both sides, and so I'd get minus 7 equals 0. Now this is my A, my B, and my C. You just need to take all of those values and you plug it in. So I get negative B plus or minus the square root of B squared minus 4 times A times C. And it's all over 2 times A. Now from there, you just want to simplify it. So I'm going to get negative 2 plus or minus the square root of 4. Now 7 times 3 is, no, negative is a positive. 7 times 3 is 21 times 4 is 84, all over 6. And so that gives me negative 2 plus or minus the square root of 88 all over 6. Now I can reduce this even further. I'm just going to rewrite it. Now the square root of 88, I'll do that off to the side. That breaks down into 4, and the square root of, sorry, 4 and 22. So that breaks down into 4 and 22. The square root of 4 is just 2, so I get 2 square root 22. And so I'm going to have negative 2 plus or minus 2 root 22 all over 6. Now you should notice that there's something in common here, right, between these values, but we can only reduce when we have common factors. So I have to factor out a 2, so I get negative 1 plus or minus the square root of 22. And then I can break the 6 into 3 and 2. And so now those 2's will cancel out. And so I have negative 1 plus or minus the square root of 22 all over 3. Next example, I need to take this statement and set it equal to 0. So x squared plus 5x plus 8, set that equal to 0. So this is my A, this is my B, this is my C. So plugging everything in, I get negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So I'm going to get negative 5 plus or minus the square root of 25 minus 32 all over 2. And so that's going to be the same as negative 5 plus or minus the square root of negative 7 all over 2. Now I have a negative inside of my square root, so that's the same as I. And so breaking this into the a plus bi form, I would get negative 5 halves plus or minus I root 7 over 2. Now the discriminant, this isn't really, you're not solving for anything. What it does is it gives you information about the quadratic equation. And the discriminant is actually just this portion of my quadratic formula. It's just that portion there. And so it's going to allow us to find the number of solutions and the type. So when you do this discriminant and your answer is 0, you know it's going to be one real solution. When you do the discriminant and it's greater than 0, which means it's positive, it's going to be 2 different real number solutions. And then when you do your b squared minus 4ac and it's less than 0, which means that it's negative, you're going to get 2 different imaginary solutions or complex conjugates. So let's try one of them. X squared plus 5x plus 8. I do b squared minus 4ac. So that's going to be 5 squared minus 4 times a times c. And that's going to give me 25 minus 32, which is the same as negative 7. So with the negative 7 here, it's negative, so therefore I can describe this graph as saying it has 2 different imaginary solutions. Or complex conjugates, however you want to say it. Now we're going to look at equations that are going to be reducible or can be rewritten as quadratic. This could be rewritten as x squared squared minus 5x squared plus 4. And so because of that, it kind of has that same pattern of a quadratic formula. Now it might be easier to visualize it by just using u substitution. If we say u is x squared, then I could rewrite this as u squared minus 5u plus 4 equals 0. Now that's a lot easier to visualize, and I can factor this. So this is going to turn into u minus 4 and u minus 1. And so I can rewrite this as x squared minus 4 and then x squared minus 1. I just basically resubstituted the x squared back in for u. And so now this turns into x plus 2, x minus 2, x plus 1, x minus 1, because it's all difference of squares, and this all equals 0. So I can say my x equals negative 2, positive 2, negative 1, positive 1. Now a hint is typically this value is what we're going to be substituted in for. Okay? That's typically the hint. So and we'll probably see that a little bit more apparent in our next example. So if I have t to the 2/3 power minus 2t to the 1/3 power minus 3 equals 0, I'm going to say t equals, so t to the 1/3 equals u. Remember I said this is that term that we want to use? Because if I resubstitute that back in, I'm going to get u squared minus 2u minus 3 equals 0. And so now I can factor this into u minus 3 and u plus 1. So resubstituting t to the 1/3 in there, I get t to the 1/3 minus 3 and t to the 1/3 plus 1. So now solving for each one, I'm going to say t to the 1/3 minus 3 equals 0. So solving for that one, add 3 to both sides, and I get t to the 1/3 equals 3. Now, how do I get t by itself, right? That's the question there that we're going to ask ourselves. Now, there's two things. Remember, when I just have a variable like x equals 4, this is actually x to the first power. So our goal here is we want that t to be to the first power. The second thing, we can realize that if I had x squared squared, you multiply those values together. So to turn a 1/3 into a 1, you would have to multiply by 3. So if I take that entire statement to the 3rd power, and what you do to one side you have to do to the other, you're going to end up with t to the 3/3 equals 27, which is the same as t, because 3/3 is 1. And so we get t equals 27. Our next one, t to the 1/3 plus 1 equals 0. Solving for that. So I get t to the 1/3 equals -1. You just take the same step. Take it to the 3rd power. So it becomes t to the 3/3, which is t. -1 to the 3rd power is -1. And so that is your answer. And that's the end of this lesson.